Hi library friends, this is Miss Cindy from the Crown Point Community Library, and today I want to bring the library into your home with a simple science experiment. So I was thinking the other day, we have all this snow on the ground and it would be neat to do some type of science experiment with the snow. So this is a science experiment that you can redo at home, that you're just going to collect some snow, you need some ice and you need some water. And then the only other thing that you will need is you will need 3 containers that are exactly the same size. So when we do science, we have something that we call a control. And a control is what we start with. So my control in this is I have a jar and I have it filled to the top with water. That's going to be my control. So I want all of the rest of my jars to be the same size because that will give me the best results. So what I want to do is I have a jar that has snow and just filled up to the top. I just went outside, scooped up some snow, packed it down, and then I have a jar that's filled with ice cubes, again, all the way to the top. So all of these 3 jars are the same size. They're all filled the same exact, but I want to find out which one is going to melt the fastest, and I want to see how much liquid is left in the jar after they melt. So what I would do when I'm starting a science experiment is I would start with we make a hypothesis. And a hypothesis is just a fancy word for we make a guess of what we think is going to happen. So right now I want you to think about it. And obviously we're not going to worry about our water because our water is not going to change. It's going to stay exactly the same. But we're going to think about our snow and our ice cubes. Which one of those 2 things do you think is going to melt the fastest? Think about that right now. And if you have a piece of paper, you could write it down, or you could tell somebody, because then we're going to see if you were right. So the other question I would like you to try to think about is which one, the snow or the ice, is going to have the most liquid when it completely melts. So those are the 2 hypotheses that we're going to make, and then we're going to test it out and see. So once you make your hypothesis, the next thing is we have to wait because we're waiting for snow to melt and ice cubes to melt, and that could take a little bit of time, right? So what we're going to do is now we're just going to let these set them aside, and watch and see what happens. I would submit, when I talk about how we have to have controls, we want to make sure that all of our variables, and variables in a science experiment are all those little pieces of the science experiment. So we want to make sure that all of our variables are the same or don't change. So our variables, the only variable that's different is the snow and the ice and the water. But the jar variable is the same. And it could even be a glass. You could even use a glass or a plastic cup or whatever. It just has to be the same size, the same shape. So that's one of our variables. One of our variables is our room temperature. So I don't want to take my snow and put that next to my stove and take my ice and put that on my back porch where it's super cold, because that's going to change the science experiment, right? Instead, I want all 3 of these jars to sit right together. I also don't want them touching each other because the temperature of my jar in the middle might have an effect on the two sides. So I just want to have them separated a little bit, and now I'm just going to let them sit. You may even want to, at this point, make a guess and see how long you think it's going to take for the ice to melt. Do you think in an hour all that ice will be melted? 2 hours? 30 minutes? And what about the snow? How long do you think it's going to take for the snow to melt completely? Well, you think about it, and I'm going to pause my video, and then I'm going to come back. This would be a good time if you're watching this and you want to be surprised, turn it off and then come back to it later, because I am going to come back and show you what I learned by doing this experiment and tell you why we got the results that we did. So stay tuned, and I will be back in a little while. Okay, so I'm back, and I don't know if you noticed this, but I'm not even wearing the same clothes that I was wearing when I was doing this before. And that is because when I started this science experiment, it was like 2 o'clock on Friday afternoon. And what happened is when I went to leave work on Friday at 5, all of my ice was still frozen. Well, there was a little bit of water in it, and the snow was maybe half melted. So what that meant is I covered them up so that they wouldn't evaporate. And evaporation is when water it goes into the air, and I didn't want that to happen. So I covered them all up, and I left them on the table, and now it's Monday morning, and I'm back, and this is what I found. So now they've all melted. So I don't know how long it took each one to melt completely. So that is something that you can check out on your own by timing it. But look at the results. It's very interesting. So obviously the water was our control, so that stayed the same. That did not change at all. And so it's still a full jar. But remember our ice, our ice was filled all the way up, right, to the top. And now if I look to see, can you see how much water is left in there? So although that jar was filled completely with ice, when it melted, it made about half the amount of liquid of water than if we filled the jar completely with water. All right, so what about the snow? So the snow, we ended up with about a third of the snow and resulted in water, turned into liquid. So why do you think that is? So water stayed the same. When we fill a jar with water, this is what we get. We get 100% all the way. When we fill a jar with ice, once it melts, we get about half of what we had to start with. And if we fill a jar with snow, we end up with about a third of what we had to start with. So why do you think the snow, we got less water than the ice? Why, when it melted, did it end up with less than ice cubes? Especially since our ice cubes were big and they didn't fill all the space. The snow, I packed that snow in there. It was full of snow. It seems like there wasn't much room for air, but in the ice one, there was lots of air around those ice cubes. So why would that be? Well, we know that water is the liquid state. So water has different states. So there's the liquid state. We know that ice is the solid state, right? So the molecules that are in water, when they're frozen, they stack together tight. When they're just water, the molecules are free to move around, and that's why a liquid is something, when I pour it, it will move, it'll run off the table, right? The ice cubes stay the same. They don't change. If I put them on the table, they're gonna sit there until they melt, and then they'll start spreading out. That's because the molecules in ice are packed together really, really tightly. And so it's very, very dense, it's thicker. Where in snow, have you ever seen a snowflake? A really fun science experiment to do during the winter, and this is the great winter for it because it seems like it snows just about every day, is to take if you have black construction paper at your house, take a piece of black construction paper, and if you don't have black construction paper, if you stop by the library and ask me, I will give you a sheet of black construction paper to take home, okay? So take that black construction paper and put it in your freezer. And the reason you want to put it in your freezer is you want it to be really cold. So you want it to be frozen. So you're going to freeze that piece of black construction paper, and then when it's snowing, go outside, take your black frozen construction paper and take it out into the snow and catch some snowflakes. And because your paper is frozen, the snowflakes won't melt right away. And you can stand out there and you can catch snowflakes and you can look at them and look at the pattern, because snowflakes are crystals and there's a pattern to them. But if you look at snow closely, you'll see that there's a lot of space around those crystals. And so that's all air. So even though we packed that snow in here, there was still those little air pockets around each one of those snowflakes and each one of those crystals. And that is why there's not as much liquid in each snowflake as there is in a piece of ice. And that is why our snow ended up with the least amount of ice. I hope you enjoyed this science experiment. I just encourage you to try it out on your home, out at home, and see if it works for you. I'd be really curious to know how much time each one took. Like I said, I had to leave, so I don't know how long it took each one to melt. But I would be curious to find out what you've learned, and try out that experiment with black construction paper. And if you need a piece, stop by the library, and I would be happy to give you a piece to take home. Check out our library Facebook page. There's other science experiments and other things that you can do. There's a story time all about snow, how to make frozen hot chocolate. So there's lots of winter activities that you can do at home. Take care and have a great day.